How Bitcoin can go carbon negative with landfill gas. Bitcoin, the world's leading cryptocurrency, has been long criticized for its environmental footprint. The energy intensive process of mining, where powerful computers solve complex mathematical puzzles to validate transactions and earn rewards, consumes vast amount of electricity, often sourced from fossil fuels. This has led to significant carbon dioxide emissions, with estimates suggesting Bitcoin's annual carbon footprint rivals that of entire nations like Greece or Sri Lanka. However, the innovative solution is emerging that could not only mitigate Bitcoin's environmental impact but potentially make its network carbon negative, powering mining operations with landfill gas. This approach leverages methane, a potent greenhouse gas emitted from decomposing waste, to generate electricity, turning an environmental liability into a sustainable energy source. Here's how Bitcoin can achieve carbon negative through landfill gas and why it matters. The environmental challenge of Bitcoin mining. Bitcoin operates on proof of work consensus mechanism, requiring miners to compete for rewards by expending computational power. This process demands enormous amounts of electricity, estimated to over 120 terawatt hours annually, comparable to the energy consumption of countries like Portugal. Historically, much of this energy has come from fossil fuels, particularly coal and natural gas, due to their affordability and availability in key mining hubs like United States, Kazakhstan, and until recently China. In 2022, a study estimated that Bitcoin mining produces 65.5 megatons of CO2 per year, contributing to global greenhouse gas emissions and exacerbating climate change. The environmental critique of Bitcoin has fueled debates about sustainability. Critics argue that its energy demands undermine global efforts to transition to cleaner energy systems, while proponents counter that Bitcoin's decentralized nature and economic incentives could drive innovation into renewable energy adoption. Enter landfill gas, a renewable yet undervalued resource that could flip the narrative on Bitcoin's carbon footprint. So, what is landfill gas? Landfill gas, or commonly known as LFG, is a natural byproduct of an organic waste decomposition in landfills. As food scraps, papers, and other biodegradable materials break down anaerobically without oxygen, they release a mixture of gases, primarily methane and carbon dioxide, with trace amounts of other compounds. Methane has particularly potent greenhouse gases with global warming potential 28 to 36 times greater than CO2's over a 100-year period and up to 84 times greater over 20 years. In United States alone, landfills account for approximately 15% of methane emissions, though some studies suggest this figure could be higher. Traditionally, landfill methane is either vented into atmosphere, worsening climate change, or flared, a process that burns the gas and converts it into CO2, reducing the warming potential by about 91%. However, flaring still releases emissions and wastes a potential energy resource. Capturing and utilizing landfill gas to generate electricity offers a dual benefit. It mitigates methane emissions and provides usable power. This is where Bitcoin mining comes in. Now let's see the mechanics of landfill gas powered Bitcoin mining. The concept is straightforward yet transformative. Instead of venting or flaring methane, landfill operates can install system to capture the gas and feed it into generators or micro turbines. This device combines the methane to produce electricity, which is then used to power Bitcoin mining rigs. Specialized computers known as ASICs. Because Bitcoin mining is local agnostic and can operate anywhere with energy source, it's uniquely suited to tap into landfill gas at sites that might otherwise lack infrastructure to connect to the grid. For small and medium-sized landfills, this approach is particularly compelling. Large landfills often sell captured methane as renewable natural gas to utilities or industrial buyers, but the high capital cost of pipelines and grid connections make this uneconomical for smaller sites. Bitcoin mining, however, requires no such infrastructure. Mobile mining units can be deployed directly at the landfill, monetizing the gas on site and turning a liability into revenue streams for municipalities and private operators. Carbon negative potential. The key to Bitcoin's carbon negative potential lies in methane's oversized impact on climate change. When methane is combusted to produce electricity, it is converted into CO2, which has far lower warming potential. For every ton of methane captured and burned, equivalent to 20 to 25 tons of CO2 emissions is avoided. By using methane's 20-year global warming potential of 84 adjusted for combustion efficiency. If Bitcoin mining operates run entirely on landfill gas, they not only eliminate their own carbon footprints but also offset emissions far beyond what they produce. Consider a hypothetical scenario. A small landfill emits 100 metric tons of methane annually. If vented, this equals to 2,100 tons of CO2 equivalent emissions. By capturing and combusting this methane to power Bitcoin mining, landfill avoids these emissions, releasing only about 275 tons of CO2. The net reduction of 1,825 tons of CO2 equivalent emissions per year. If this energy powers mining operations that could be otherwise rely on coal or natural gas, the savings compound further. Proponents argue that scaling this model across thousands of landfills worldwide could make Bitcoin network carbon negative. Daniel Batten, co-founder of CH4 Capital, estimates that deploying landfill gas projects at scale could mitigate emissions 45 times more effectively per unit of power than adding solar panels to the grid. Even if a small percentage of Bitcoin hash rate shifts to landfill gas, the network could offset more emissions than its energy sources generate. Now let's look at the real world examples and momentum. This isn't just theoretical. Companies like Vespine Energy and Nodal Power are already providing concept. Vespine, which raised $4.3 million in 2022, installs microturbines at landfills to convert methane into electricity for Bitcoin mining data centers. Its first 1.5 megawatt pilot site targets smaller landfills ignored by traditional energy. Nodal Power, meanwhile, has used landfill gas to pioneer off-grid mining, demonstrating reliability and efficiency. Both companies highlight Bitcoin's scalability and transportability as key enablers, allowing them to monetize standard energy sources that other industries can't easily access. Peer-reviewed research suggests these efforts. A 2024 study in the Journal of Cleaner Production found that integrating Bitcoin mining with landfill gas to energy systems could reduce methane emissions significantly, with a single small landfill mitigating over 2,187 metric tons of CO2 equivalent emissions annually. As more operators adopt this model, the cumulative impact grows. Now let's look at some challenges and criticisms. Despite its promise, landfill gas-powered Bitcoin mining faces hurdles. First, the supply of landfill gas is finite. Landfill produces for 30 to 50 years, with output declining after closure. Miners must eventually relocate the sites, requiring flexibility and investment. Second, critics argue that methane could be used for other purposes like heating of grid or grid electricity. However, for many landfills, these alternatives are unprofitable due to infrastructure costs, whereas Bitcoin mining offers immediate viable solution. Skeptics also question whether this approach absolves Bitcoin of its broader energy problem. If only a fraction of the network adopts landfill gas, the majority may still rely on fossil fuels, diluting the impact. Transitioning to a significant portion of Bitcoin's hash rate to carbon negative sources will require coordination, incentives, and possible regulatory support. Now let's look at the bigger picture. Bitcoin's potential to go carbon negative with landfill gas is a game changer. It aligns economic incentives with environmental goals, offering a scalable way to tackle methane emissions, a critical yet often overlooked drive of climate change. Unlike solar or wind, which reduce future emissions. Landfill gas projects address existing emissions today, providing an urgent climate solution.